Holy crap, Qwen3-30B-A3B honestly is a model that caught me off guard. If you watch my evaluation of the big model, the 235 billion parameter model, you will know that I'm not a fan of using that for coding. But I'm always looking for local models. So I actually started out testing the Qwen3-32B parameter model. And I was very disappointed with that. But then I found Qwen3 30 billion A3B, which is a mouthful to say, but basically what this is a 30.5 billion parameter model, if I remember right, with 3.3, a little over 3 billion parameters active at any time. And I have come to the belief that MoE, which is mixture of experts, could be the key to local models. I just want to run through a few things with you today to kind of explain why. So first off, I'm going to talk about Qwen3, the model in particular, the 30B-A3B one, and probably make a bold claim that this is the best thing about Qwen3. I'm going to give you a little bit of details around what MoE is if you're not familiar. If you are, you can skip ahead across that part. Then I'm going to show you the local benchmarks on my hardware. And honestly, my mind is freaking blown by these models, by how just the performance of them. And I also do a bunch of comparative benchmarking as well to kind of show you how this model stacks up against other models. And then we'll go into, can it actually code? I've actually been working with my system prompt, my local override system prompt, to actually make it work pretty well with this particular model, the 30B-A3B, which is kind of crazy because I can load more context window than normal because of just the way this model's set up. And then I'll close it out with some summaries, thoughts on the overall model and testing that we did. And then I have actually been working on a local model eval where I'm bringing basically 32 billion and less models in, and I'm running them through a gamut. And I'm trying to build that out. So just maybe give you a quick update on that. So first off, this is an amazing link if you have not checked out this explanation of mixture of experts, but this should give you a really interesting idea. The main thing is there's this gating network, which activates individual parts of the model. And so you can have 3.3 billion or whatever the exact number of billion parameters active at any particular time based on the query that's being done to the model. So what does this mean in practice is the advantages are just so clear. Much lower computing needs because the number of experts, you're only activating a few of them per input. It reduces your flops drastically. It can also support massive models like 1.6 trillion parameters or even bigger. And it does really excel at specific tasks. So depending on how the model's trained or whatnot, it can just be incredibly good. There is some disadvantages, but some of these are kind of in line with regular models anyway. So, all of it has to be stored in memory. So even though you're only activating 3 billion parameters or 3.3 billion parameters at a time, you do need to have the entire model loaded into memory. So it doesn't negate the fact that you need you need a lot of VRAM if you're running it on your local computer. There is some training complexity that I was reading about too, where basically it's prone to overfitting, so you have to be kind of careful with it. So just something to know whenever we're dealing with these MoE models. And it's best for clustered data. It's really not as good for uniform distribution. It's based on the research that I was doing. And another thing I learned about is this is not the first mixture of experts model that's been open source that's smaller. I found this one, which is a Mixtral 8x7B that released in December 11th of 2023. It's been still getting downloaded. It got downloaded 45,694 times last month for an older model. It's pretty interesting to me. So it's one that I might check out, but it's kind of old now. I don't think it's probably as valuable anymore. But this one is a sparse mixture of experts. I had made a claim before that I didn't or couldn't think of any MoE models that were in the smaller size. And so I found one. This one's still bigger. I think I read, 46.7 billion parameter model. So it's not quite as small as the 30 billion parameter model that we're going to be talking about today. And that gets us to this. So you can see here, there are 128 experts. They activate 8 at a time. The context length is 32,768, so pretty low, and that is a problem, but you can apparently increase that with YARN. And but the model I'm using, I can't even load that much locally. I can get about 9 or 10,000 pretty regular without spilling into system RAM. Number of parameters with non-embedding is 29.9 billion. Number of parameters in total is 30.5, and 3.3 billion are activated. I'm so excited to show you guys this, but check out the freaking speed. I'm going to show you the raw data too, to show you how the quant level and everything, if you're interested in that. To just hang tight, I got a slide for that. So I compared this to Qwen3-30B, and I compared it to Mistral Small 24B and Gemma 327B. And these models are about 4 times faster than Qwen3-30B, whether it's thinking or not. And the reason that you start seeing thinking like drop in performance in the way that we're doing this is just because normally the number of tokens increase, and the more tokens you get out, it just gets slower, but not super slow. It's still incredible speeds. And the token counts, because the other thing I like to look at is how many tokens are they outputting, are more or in line with the other models. So we're comparing very similar outputs here, with Mistral Small being kind of the lone outlier there because it's sitting a little over 1,000 tokens. Now, these tests were all done 3 times, and I took basically the median of those. So I took the median run of the 3 tests with the same prompt across all of them. The next thing that I want to do is just show you the raw data, because you can see the quant levels that I'm running, the total tokens. This is basically that median run. All of these are ran with a quant level of Q3. The only exception to that is Gemma 327B. I wanted to run the QAT models, and they only are quantized at Q4_0 in LM Studio that I could find. The context window is all 6,000. I do that because that is what I can fit comfortably without spilling into system RAM. And that's in particular for the bigger model, the Qwen3-30B model. It makes it a little bit harder to fit that in because of the bigger size of that, even at the Q3 level. Now, they are fast, but compared to what? So I got to thinking, 88, go back to this a second. 84, 80. I mean, we're looking at 80 tokens. I had some that were low 90s if the prompt's small enough. That's incredible speeds. But what does that compare to? I was thinking, like, I know when I was running Llama, you know, like I think it was a 3 billion parameter model. I can't remember if it was Llama, but I was running 3 billion parameter models. I think it was actually Gemma. I could get close to 100. So I got to thinking, like, what model size is this comparing to? And honestly, it gets about the speed of 8 billion parameter models. 12 billion on my computer gets a little over 50. The 8 billion, you can kind of see there, I've got the Qwen3-8B, and I've got the Llama 3.2-8B. And both of those, you know, are about in line. Actually, the Llama 3.2-8B is slightly faster. Qwen3-8B is slightly slower. And then I actually tested the Gemma 3.4B QAT model too. And that thing is blazing fast, but it's not that great of a model. Here's all of the raw data that I ran. And you can pause here. I'm not going to stay on this very long. But if you look at the bottom, the one thing I do want to call out is I did actually test speculative decoding. And I found that it actually slows the model down, which I haven't quite figured out. But Qwen3 has a 0.6 billion parameter model that I ended up using. The acceptance rate was 62, 63%. You know, I typically like to see that in the 70s in the ones that perform well. But right now, until I figure out how to configure this, I would not recommend using speculative decoding on this at all. The next thing I want to do is I just want to run into RooCode and show you how that 30B parameter model works. And I'm going to show you how to actually disable thinking as well if you want to. All right, so I'm going to start off by saying I have updated my system prompt. I have it completely overridden, so you're actually going to see a big yellow warning here. The reason I do that is I need the system prompt to be as small as possible. I have LM Studio loaded up here. Currently, I have my context link set to 9,000. You can see in my configuration here that I'm using 20.4 out of 24 gigabytes of my VRAM. So I probably could bump that up a little bit, but I have to be a little careful because if I go too much, it'll spill over. So I usually like to sit around this. This is about what I look for here. The memory usage, basically when I load a model in, I always monitor how much of my system memory changes. And it'll spike a little bit, but it should come back down to where it was pre-model load. That's just a good way to be able to tell, if the model is actually spilled over at all. And just to show you here, I've got this running. I just did a very simple test with the no think on. You can see my compute popped up. That's working perfectly. And in that particular one, I got 90.91 tokens per second at 1,073 tokens. Just astronomically good speeds. The other thing I wanted to tune real quick here is I want to make sure we have our temperature set to 0.6. And that's important because this model just seems to do a little bit better, especially when you're using thinking mode, having it set to 0.6 there. And one way to do that is if you go to your developer tab, you can make sure you've got the model ready, you're running your server, and then you set your preset to reasoning models. I created this one. If not, otherwise you can just manually change that to 0.6. I also lowered the top case sampling to 20 based on some feedback that I got. We are not going to put draft model in there for speculative decoding because we do not want it to be slower. All right, so now we have our system prompt overridden. We're in RooCode. And one of the big problems that I always run into in RooCode with smaller models is just the ability for them to actually call tools. So I prepared a couple prompts. They're very basic. We're going to run through them. First off, just to show that it can actually work with RooCode. So the first thing I'm going to do is I'm just going to create a game of Tetris in Tetris.py. This is going to have think on. And the speed here, as we kind of watch this go, is actually pretty cool. So we're hitting about 84% of the compute. We're automatically calling the tool, which is freaking awesome because a lot of local models won't do that. So that has me very happy. If you do want this, I'll have a link to a drive doc that I share this in. I'm going to be honest with you, I keep it up to date. So when I change stuff, you'll just have to keep an eye on it because I'm changing it periodically as I improve ways to actually get it to talk. And actually, RooCode will do an update too, and that'll end up breaking it. So I have to fix that, and I'll update it as well. So now we've got our Tetris.py game. Now this game is not going to be good. I just can promise you that pretty much 100%. Let's just see if it even runs here. Okay, so we have that. The piece isn't falling, but apparently I can hold down to make the piece go, and I can move it side to side. So we had a functioning Tetris game, not really, but we did get a game that didn't crash, and we could now go and iterate on that. So we could say, this is the interesting thing too, because can it actually take and edit this file and diff it properly? This is where it gets kind of sketchy with these models. I sent off a message. I told it to make the pieces fall on their own instead of having me have to push down to make it fall. And we're going to do the next test without thinking on, after I kind of show you just some of the tool calling here. And then we're going to go to one of my Python scripts that I've actually been building for my eval system and just see if it can make some changes to that without messing up anything. One of the things that I just messaged LM Studio about is I really hate that LM Studio doesn't return token information as part of their API if you have streaming turned on, because this always will show 0 here. So don't get scared by that. It's an annoyance. If you really do want to see that, you can rebuild RooCode. It's an open source project, and you can just literally go into the LM Studio file where they actually do the connection to LM Studio, turn off streaming, and it literally will work. Unless something has changed. There for a while, I was running my own custom version to be able to do that. This is doing a lot of thinking now. So I'll probably stop here and then come back when it's done. All right, so I let this run for a while. It did actually get hung up, and it's not able to actually call tools, at least to modify the file. So that's a little bit unfortunate. Let's try this without thinking. I appreciate all of you that actually told me in the last video how to actually disable thinking. I can't believe I never realized that. But if you put no think in the query, and then follow it with whatever you want, and I've actually tried putting it at the end too, it does seem to pick that up. It does work. So watch how much faster it's going to be. All right, so it started creating the tetris.py file. We'll try running it and we'll see if it can actually modify it as well. The quality of code this put out is actually really, really bad. So it did open a window. There is some errors in it. You can kind of see those come up here. Very little code. This is no thinking. I've very consistently in my evals found that the thinking version of this code's extraordinarily better. But I will say the thinking version, on average, it's doing like 20 to 30% better in my evals than the non-thinking version. So now I'm going to tell it that I don't see any pieces falling, and I tell it not to think. And let's see if it can actually edit the file properly. But the thing about it is, if we can get it to the point where it can actually modify and apply diffs, it starts becoming a little bit of a contender for an intern role in my micromanager. I'm actually getting a little worried here. I've got a bunch of like spinning edit files. Oh, whoa, it actually edited. Woo! I ended up with an error, so I'm going to go ahead and give it that error and see what it ends up doing here. It's just basically a simple one. It's an unknown color name, but I want to see if it can fix that properly. And it fixed it. So now we actually have a piece falling. I can move it left and right. Let's see if it gets to the bottom and stops. Nope, it just goes off the screen. Very interesting. Really, really promising, though, to be honest. Even though I wouldn't say this is a really good coder of any kind, but it did even read the terminal. I was going to actually paste the error in there, but it actually picked it up properly, and it fixed it, which I thought was super cool. I did just run a test on my quickgrade.py, where I run this to actually do some of the scoring on my evals. And I asked it to tell me some things that it can improve on. Now, I would say this very much feels like an intern. Like, if I were to ask an intern this, they would probably come up with the same sort of answers. But ultimately, I think it's okay. Unfortunately, this model is just not an amazing coder. It got me to think, like, could this actually be good at documentation? Because I am always looking for valid things to be able to use local models for. And if it's fast enough and I could actually run and do some like local documentation, or maybe even generating, I don't know, summaries of files for the AI that they could actually read, I don't know, it could be worth exploring. And honestly, reading through this, I basically gave it the prompt to build me a markdown file that details out each function and what it does. And it did a pretty decent job here. I don't know, I need to think about that a little bit more. It won't be a model that I use for coding, unfortunately, and it's scoring, like I said, the thinking one's scoring better, but it's not scoring, I don't think, high enough. I think the GLM ones are just better. But man, I hope they do an MoE version of like a coder model or something, if that's even possible. I really do want to see local models like take on this path, because I'm able to run them at something that's a reasonable rate. I am so freaking excited that we have a model that's 30 billion parameters that can run as fast as it does on my hardware. And I know that it probably can do some things that I just haven't even thought about yet. Like, I was thinking about hooking it up to some of my agentic workflows that I run locally. Like, I have this one that goes through and I use local models for it. Every once in a while, I take my spam email and I run an agentic framework that goes through and basically classifies and categorizes each of my emails based on, its importance to me. So I might stick it in there to see what it does, because it runs so much faster. I'm using Mistral 24B for that now, and you saw the speed difference between that one. I'm super excited about that. So I think this model has some use locally. It's just not for coding. Anyway, I think that's going to about wrap it. Just to summarize everything up real quick, man, I'm so pumped about the MoE models being local and at the speed that they run at. It really makes me want to figure out something to use that model for. When you're getting like 18 to 22 tokens per second with these big models, the big 32 billion parameter models, it's not really that fun to run them because it's kind of slow. It may not seem like it, but it's slow, especially when it's a thinking model. Man, you get into 80s and 90s, and if it's small enough of a problem, sometimes you can even crack 100 with my computer with it. Like, that is pretty dang sweet. If you have a Mac, I've heard it's performing really good on there as well. So I think this model is probably the most exciting thing to come out of Qwen 3 because of just its cost for inference, how quickly you can run it. I just wish it could code a little bit better. So my hope is that we get a coder model that has this MoE framework that runs at this speed. And man, if it was at the level of GLM, dang, I would just be incredibly. I'd be so happy. That would be able to. That would lower my cost a lot because I would redo probably an entire framework around driving more work down into that model to do a lot of the diffing and stuff if it could get good at that. Anyway, I appreciate you all. If you made it till the end, let me know in the comments below, what your thoughts are on this model. Are you excited about this tech? All that stuff. Otherwise, until next time, everyone, peace out.